Welcome to Sleepy Story Facts, and to this gentle nighttime story created to help you unwind and drift into deep, restful sleep. As you settle in, you might be lying in bed, tucked under a soft blanket, or listening in the quiet glow of a bedside lamp. Wherever you are, this bedtime story is here to walk your mind away from the noise of the day and into the calm, steady rhythms of our solar system. Let your body become heavy and relaxed, and allow each breath to arrive a little slower, a little softer. With every exhale, the day can fade further into the distance, like a landscape slowly disappearing beneath a rising night sky. Imagine your thoughts becoming like small, distant stars, gently twinkling and then dimming as you focus only on the sound of this calming narration. This is your time to rest, to let go, and to float through a peaceful sleep story filled with quiet wonders of space. In your mind's eye, picture yourself drifting just beyond Earth, looking back at our pale blue world shrinking behind you. Ahead, the solar system stretches out like a great, dark ocean, sprinkled with planets, moons, and rings glimmering in the starlight. There is no rush here, no need to get anywhere fast. Tonight's journey moves in slow, graceful arcs, curving from one gentle fact to the next, like a long, soothing nighttime story designed to help you fall asleep and stay asleep, rather than racing in a straight path from the sun to the edge of our system. Imagine spiraling calmly outward. You drift past warm, bright worlds and colder, shadowed ones, past delicate rings made of ice and rock, and over silent craters frozen in time. This is not a tour of numbers and equations, but of feelings and images. Invisible winds, glowing storms, tilted worlds, and hidden seas sleeping beneath the ice. Each stop along the way offers a quiet, fascinating detail, just enough to hold your attention while your body relaxes more deeply. As you float farther from the sun, the light grows dimmer and softer, like the last glow of evening slipping into night. Out here, at the far reaches of the solar system, waits a calm, deep blue world, Neptune. Even though it is so distant and cold, Neptune is anything but still. High in its atmosphere, invisible currents race around the planet at astonishing speeds, forming one of the most dramatic weather systems in our solar system. Neptune's winds move faster than the speed of sound on Earth, sweeping through its upper atmosphere in powerful, continuous streams. For comparison, they travel several times faster than a typical passenger jet, circling the planet in roaring, but soundless flows. Beneath this activity, the planet quietly releases heat from its interior, energy that may help drive those incredible winds despite the darkness and cold so far from the sun. The air on Neptune is made mostly of light gases, hydrogen and helium, mixed with methane, that gives the planet its serene blue color. Within those blue layers, the supersonic winds sculpt enormous, pale storm systems that drift and shift across its face. From a distance, Neptune looks calm and tranquil, like a marble of deep ocean glass. Yet its atmosphere is always in motion. As you imagine this distant, windy world, you might feel your own thoughts moving more slowly, like clouds being stretched and smoothed by a gentle breeze. Now let your awareness slide inward again, toward a smaller, quieter planet painted in rusty reds and soft browns. Mars. As your mind glides over its surface, you pass above volcanoes, ancient plains, and dust that has been blown and reshaped over millions of years. Near the Martian equator, an enormous scar cuts across the landscape. A canyon system so vast it could stretch from one side of a continent to the other back on Earth. This canyon, known as Valles Marineris, runs for thousands of kilometers across the planet, longer than many countries are wide. In some regions, its walls drop down for several kilometers, forming cliffs and chasms far deeper than Earth's most famous canyons. Instead of being carved mainly by rivers, as many Earth canyons are, this great rift may have opened when the planet's crust stretched, cracked, and sagged long ago. Over time, volcanic activity and erosion likely deepened and widened it, leaving behind a frozen record of Mars's more turbulent past. From high above, Valles Marineris looks like a broad, branching wound across a silent world. Yet, even this immense feature is still and quiet now, its slopes dusted with fine red particles and its depths filled with shadow. As you picture this enormous, unmoving canyon under a pale Martian sky, you may notice a similar feeling settling into your body, a sense of deep stillness, of everything becoming slower and more spacious inside you. Gently now, the scene shifts again, and your attention moves inward toward another familiar neighbor of Earth, Venus. Often called Earth's sister because of its similar size and rocky nature, Venus glows in the sky as a bright, steady light. But behind that soft radiance lies a world very different from our own. One of the most striking differences is something you cannot see at all. Venus does not have a strong, global magnetic field like Earth does. On our planet, a swirling, molten outer core creates a protective magnetic bubble that shields the atmosphere and surface from much of the sun's charged particles. Venus, however, seems to lack the vigorous internal motion needed to generate such a shield. Its core may be more sluggish or partly solid, and without a strong magnetic field, the planet is left more exposed to the steady flow of solar wind streaming from the sun over long stretches of time. This unshielded exposure has helped strip lighter particles from Venus's atmosphere, slowly altering its composition. Combined with other powerful processes, this has contributed to the thick, heavy air and extreme heat that now blanket the planet. When astronomers look at Venus today, they see a world that might once have been more Earth-like, but that followed a very different path, becoming a hot, dense, and hostile environment. As you think about these three distant neighbors, windy Neptune, scarred Mars, and glowing Venus, notice how each carries its own quiet story. Written over unimaginable lengths of time, the solar system is full of such peaceful, patient transformations, unfolding far beyond the concerns of any single day. Let that sense of vast time and distance soothe you, as if your worries were shrinking down to tiny specks beneath a great, star-filled sky. As you continue to drift through this gentle sleep story, imagine gliding past the pale blue and soft teal clouds of the distant ice giants. Far below those calm-looking cloud tops, the pressures and temperatures rise to levels that are hard to picture from the safety of your bed. Deep within Uranus and Neptune, scientists think something quietly spectacular may be happening, hidden from every telescope and camera. In the darkness, carbon may be pressed and shaped into countless tiny diamonds, slowly drifting downward like a silent, glittering rain. These planets hold thick layers rich in methane and other simple molecules. Under immense pressure and heat, those molecules can break apart, freeing carbon atoms that are then squeezed into orderly, crystal-like structures. In laboratory experiments that mimic these extreme conditions, researchers have watched tiny diamonds form from hydrocarbons, suggesting that similar processes could be taking place inside these distant worlds. Over incredible spans of time, showers of diamond crystals may sink toward the core, turning parts of these planets into slow-motion storms of shimmering, sinking gems, leaving the ice giants behind. Your attention returns to the planet you know best, Earth. One of the most remarkable things about Earth, quietly shaping its surface over millions of years, is the slow dance of its tectonic plates. The planet's outer shell is broken into large plates that float on the softer layer beneath, gliding and colliding in a steady, almost unnoticeable motion. This ongoing movement raises mountain ranges, opens oceans, and recycles material from the surface back into the deep interior, helping regulate the climate over vast stretches of time. So far, Earth is the only known world where this kind of large-scale plate tectonics is clearly at work. Neighboring planets like Mars and Venus show signs of ancient fractures and volcanic features, but they appear far less active, their surfaces more frozen in place. Earth's shifting plates not only sculpt the land, but also play a role in long-term cycles that keep oceans stable and temperatures within a range where life can thrive. As you picture continents slowly drifting over eons, the timescale becomes so vast that everyday worries seem very small and distant, like tiny ripples on a deep, calm sea. Now your mind sails away from planets and moves towards some of the smaller travelers of the solar system, asteroids. It is easy to imagine them as lone, rocky fragments wandering the dark. But some of these space rocks have quiet companions. A few asteroids are orbited by tiny moons, small pieces of rock that circle around them, bound by their gentle gravity. In some cases, two similar-sized bodies orbit each other, forming a delicate partnership as they drift together around the sun. The first known asteroid moon, Dactyl, was discovered around the asteroid Ida in the early 1990s, revealing that even these modest objects can host miniature systems of their own. Since then, astronomers have identified many more examples, including pairs and systems with multiple small moons. These little arrangements of rock and companion moon drift through space in a slow, steady rhythm, like dancers turning in a quiet, endless waltz. Thinking of them can be soothing, a reminder that even in the vastness of space, small connections and gentle orbits are everywhere. From there, let your thoughts slide inward toward the closest planet to the sun, Mercury. Unlike Earth, Mercury does not wear a thick, protective blanket of air. Instead, it is wrapped in something much more fragile and delicate, a ghostly exosphere. This is not a true atmosphere, but a whisper-thin collection of particles that hover above the surface, so sparse that they rarely meet or collide. It is as if Mercury is surrounded by a nearly invisible veil, made of atoms that have been knocked loose by sunlight, charged particles, and tiny impacts from space dust. These particles include elements like sodium and potassium, along with traces of other gases, constantly escaping into space and being replenished from the surface. To the human eye, this exosphere would be essentially invisible, yet sensitive instruments can detect its faint presence, like a subtle glow of scattered atoms. Imagining this fragile shell around a small, sun-baked world can be strangely calming, a reminder of how delicate and yet enduring many structures in the solar system can be. Finally, let your awareness rest on the star at the center of it all, the sun. At its core, immense pressure and temperature fuse hydrogen into helium, releasing energy that travels outward as light and warmth. In the process, the sun quietly converts millions of tons of its own mass into energy every second. This might sound dramatic, but compared to the sun's total mass, it is a tiny amount, spread smoothly across billions of years. The light that reaches you warming Earth, driving winds and weather, and making life possible is part of this continuous, steady outpouring of energy. One day, far in the future, the sun will exhaust its current fuel and begin to change. But for now, it shines with calm reliability, a steady presence that has watched over the solar system for ages. As you picture this gentle, ongoing glow, you might feel your breath sinking with that sense of slow, patient continuity, helping you sink deeper into relaxation and toward a peaceful night's sleep as your mind continues its quiet drift through this bedtime sleep story. Imagine gliding into the soft, golden reach of Saturn. The planet itself hangs like a pale lantern in the dark, wrapped in its famous rings that gleam like thin bands of ice and dust. From far away, they look eternal and unchanging, as if they have always circled Saturn and always will. But in reality, these rings are delicate and temporary, slowly changing over time in ways that are almost impossible to notice in a single human lifetime. Gently picture the countless tiny particles that make up Saturn's rings, chips of ice, grains of dust, and fragments of rock, turning in slow, graceful orbits. Very gradually, some of this material drifts inward, guided by Saturn's gravity and influenced by its magnetic field. This process, often called ring rain, causes small streams of particles and charged material to fall toward the planet, disappearing into its upper atmosphere. Observations suggest that the rings are surprisingly young on cosmic timescales and may one day fade away completely, leaving Saturn as a simpler, ringless world. For now, though, they are still there, a shimmering, temporary ornament in the darkness, like a beautiful dream that lasts far longer than a single night. From Saturn, let your thoughts float gently back to Mars, which you have visited before in this relaxing nighttime story. This time, imagine the planet not as a quiet, frozen desert, but as a place where the thin air sometimes comes alive with motion. Mars is known for its dusty surface and the enormous storms that can grow until they wrap around the entire globe. These planet-wide dust storms can linger for weeks or even months, turning the sky hazy and dim and reshaping the landscape grain by grain. The dust on Mars is made of extremely fine particles, light enough to be lifted and held in the air, creating a reddish fog that softens the sunlight and bathes everything in a muted glow. Small gusts can slowly build into large storms as heat, wind, and the shape of the terrain interact and intensify one another. At times, these storms become so thick that they block sunlight from reaching solar-powered spacecraft on the surface, as happened to the Opportunity rover late in its long mission. Even without oceans or frequent rainfall, Mars remains an active, changing world, stirred by winds that can sweep across entire continents. Now, let your awareness drift outward again, this time toward one of Jupiter's most intriguing moons, Europa. Picture a smooth, pale world, its surface covered in ice that reflects a faint, cold light. From above, the ice shell is crisscrossed with dark lines and ridges, like cracks in frozen glass. Beneath that icy shell, many lines of evidence suggest the presence of a deep, global ocean of liquid water, hidden away from the vacuum of space. Jupiter's strong gravity gently squeezes and stretches Europa as it orbits, generating heat within the moon's interior. This tidal warming may keep the subsurface ocean from freezing solid, allowing liquid water to persist beneath the ice. Measurements of Europa's magnetic environment and chemistry strengthen the idea that a salty, global ocean lies below. What makes this especially calming to imagine is that, in the darkness beneath the ice, there may be a quiet, alien sea, warmed from below, and possibly holding the ingredients needed for life. It is a place of mystery and potential, an ocean that has never seen sunlight, yet may still be full of gentle motion and quiet currents. Once more, your thoughts glide back to Mars, but now toward a single, enormous landmark, Olympus Mons. Picture a vast shield volcano rising from the Martian plains, so tall that it reaches more than twice the height of Mount Everest. Its slopes are gentle and broad, stretching so far that, if placed on Earth, it could cover an entire large state or region. This immense volcano grew over many millions of years through repeated eruptions that slowly piled layer upon layer of cooled lava. On Earth, the movement of tectonic plates carries the crust over volcanic hotspots, creating chains of mountains and islands. Mars, however, does not have the same kind of shifting plate system. Instead, magma on Mars can rise and erupt from nearly the same spot for long periods of time, allowing a single volcano to grow larger and larger. The result is Olympus Mons, a towering, silent giant under the thin Martian sky. As you imagine standing far away and looking up at its distant summit, it becomes easy to feel very small in a comforting way, as if your worries are tiny compared to the calm, ancient landscapes of other worlds. As this gentle sleep story continues, imagine that you are still drifting near Saturn, lingering in the quiet glow of its rings. From a distance, the rings look like solid, gleaming bands wrapped neatly around the planet, smooth and continuous. But as you float closer in your mind, you begin to sense how delicate and finely crafted they really are. They span an enormous distance across space, yet they form a structure that is astonishingly thin, like a sheet of light laid carefully around the planet. Saturn's rings stretch for hundreds of thousands of kilometers from one side to the other. But in many regions, their vertical thickness is no more than the height of a modest building. Within this incredibly slender band, countless pieces of water ice and rock circle the planet together, some as small as dust grains, others as large as boulders or small houses. When the rings are viewed edge-on, sunlight can slip right past them, making them seem to vanish, as if they were nothing more than a faint line drawn across the darkness. The flatness of the rings is maintained by Saturn's gentle but persistent pull of gravity, and by the way the countless icy particles interact with one another. Tiny collisions and adjustments help keep them confined to a narrow plane, while small shepherd moons move along the ring edges, guiding and shaping the flow of material. What looks solid from afar is, up close, a vast, graceful swarm of individual fragments, each following its own quiet path, together forming something that appears smooth and serene. Leaving Saturn for a moment, let your thoughts return to Earth, the world beneath your pillow and blankets. Of all the planets in our solar system, Earth is the densest, packing a great deal of mass into its volume. Deep below the surface, a heavy, metal-rich core is wrapped in layers of rock and mantle, forming a compact, layered interior. This inner structure does more than just give Earth its gravity. It helps drive the processes that keep the planet active and protective. Within Earth's outer core, molten iron and other metals move and swirl, generating a strong magnetic field that extends far out into space. This invisible shield helps to deflect charged particles from the sun, protecting the atmosphere and the life that depends on it. As you picture the planet from space, a blue and white sphere with a hidden, powerful heart, you might feel a sense of comfort knowing that inside our world, slow, steady motions are always at work, quietly maintaining the conditions that allow oceans, air, and life to exist. Now, let your awareness drift back to the sun, but in a different way than before. Instead of focusing only on its light, imagine the sun as a vast, resonant instrument, constantly vibrating with waves and subtle motions. Within its hot, glowing layers, rising and sinking currents of plasma send pressure waves rippling through the star. These waves are like deep, continuous notes, far below any sound that human ears could ever detect. Scientists study these gentle solar vibrations to learn what is happening beneath the surface, using a technique similar in spirit to how geologists use earthquake waves to probe Earth's interior. By watching how these waves move and bounce inside the sun, researchers can map its inner structure and flows, uncovering patterns of motion and magnetic activity hidden from direct view. It is as though the sun is always humming a quiet, complex song, its rhythm carrying information about the processes that keep it shining. Finally, your thoughts turn once more to Venus, Earth's bright sibling in the sky. You have already visited this world in earlier parts of the story, but there is another detail that makes it especially intriguing. Unlike most planets, Venus spins in the opposite direction, a behavior known as retrograde rotation. If you could stand on its surface and watch the sky, ignoring the thick clouds and intense heat. The sun would appear to rise in the west and set in the east, reversing the familiar pattern from Earth. Venus also rotates extremely slowly. A single rotation takes longer than a full orbit around the sun, meaning that one Venusian day lasts longer than its year. The reasons for this unusual spin are still being explored. Some scientists think that a giant impact long ago might have altered its rotation, while others suggest that long-term interactions with the sun's gravity gradually tipped and slowed the planet over time. Whatever the cause, Venus has settled into a unique, unhurried rhythm, turning lazily beneath its thick clouds. As you picture these worlds, the thin, shimmering rings of Saturn, the dense and layered Earth, the softly vibrating Sun, and the slowly spinning Venus, let their calm, steady motions soothe your mind. Each fact becomes a gentle point of focus, something interesting yet peaceful, helping your thoughts to drift, your breathing to soften, and your body to sink deeper into rest. As this gentle nighttime story continues, imagine your awareness gliding toward the largest planet in our solar system, Jupiter. From a distance, it looks like a swirling, striped giant of clouds and storms. But what quietly orbits around it is just as remarkable. Jupiter is surrounded by a remarkable family of moons, so many that it resembles a tiny solar system all its own. Astronomers have identified more than 90 natural satellites circling this gas giant, and from time to time, new, faint ones are still added to the list. 4 of these moons are especially famous: Io, Europa, Ganymede, and Callisto. The Galilean moons first seen through a telescope more than 4 centuries ago. Each is a world in its own right, with volcanoes, oceans, ice, and ancient, cratered surfaces. Beyond these large companions lies a drifting cloud of smaller moons. Many of them follow irregular paths, some moving in the opposite direction of Jupiter's rotation, others only a few kilometers across. Together, they form a quiet, intricate dance of rocks and ice, all bound to the planet by its immense gravity. Now let your thoughts drift inward again, this time to tiny, sun-baked Mercury, the closest planet to the sun. It is easy to imagine that such a world would be entirely dry, its surface scorched by intense sunlight on one side and chilled on the other. Yet, at Mercury's poles, deep within craters that never see the sun, something surprising can endure: ice. In these permanently shadowed pockets, sunlight never reaches the ground, and temperatures stay cold enough for water ice to remain stable over very long periods of time. These shadowed craters act like natural freezers, protecting bright deposits of ice from the relentless solar heat just beyond their rims. Spacecraft observations have detected strong radar reflections and brightness patterns that match what would be expected from icy surfaces hidden in the dark. That water may have arrived on Mercury through impacts from comets or icy asteroids, or through gases once released from the planet's interior. In the deep stillness of these craters, ice survives in silence, locked away beneath walls that shield it from the blazing sun. Next, allow your mind to drift far beyond Neptune, into the dim outer reaches of the solar system, where Pluto circles the sun in a distant, elongated orbit. On its surface lies a bright, heart-shaped region called Sputnik Planitia, a feature that has captured both images and imagination. Beneath this frozen plain, there may be more than just solid ice. Evidence suggests that a deep layer of liquid water could be hiding below, forming a subsurface ocean insulated by the ice above it. The weight of the heart-shaped basin and signs of ongoing activity in the region hint at a slowly moving, possibly convecting interior. Heat from the gradual decay of radioactive elements inside Pluto, combined with insulating ice layers, could help keep this hidden ocean from freezing entirely solid. If such a sea exists, it would be a dark and remote one, warmed gently from within, quietly persisting in a place where the sun is no more than a bright, distant star. Finally, imagine turning toward the region between Mars and Jupiter, where the asteroid belt resides. Popular stories often picture this belt as a crowded maze of rocks, but the reality is far more spacious and calm. While the belt contains millions of rocky bodies of various sizes, the distances between them are enormous. A spacecraft passing through this region would almost certainly glide past without ever coming close to a single asteroid. Most of the belt's total mass is concentrated in a few larger objects, such as Ceres and Vesta, while countless smaller fragments are scattered throughout the rest of the region. Altogether, the combined mass of everything in the asteroid belt is only a small fraction of Earth's moon. These objects are remnants from the early solar system, pieces that never merged into a full-sized planet. As you picture them quietly orbiting the sun, separated by vast stretches of empty space, the image becomes peaceful, a wide, gentle expanse of ancient stones slowly circling in the dark. As this relaxing sleep story continues, imagine your awareness gliding outward again into the cool, distant region of the solar system where Uranus circles the sun. Most planets spin like gently tilted tops, but Uranus behaves differently, as if it has quietly lain on its side. Its axis is tipped so far over that, in your mind's eye, it seems to roll around its orbit like a slow, turning sphere on its edge. This unusual tilt gives Uranus some of the most unusual seasons of any world we know. Because of this extreme tilt, each pole of Uranus can spend decades pointed toward the sun, followed by decades turned away into darkness. One pole can bask in continuous daylight for around 40 years, while the opposite pole rests in a long, deep night. Over time, they trade places, moving through seasons that last longer than an entire human life. The exact cause of this sideways orientation is still uncertain, but many scientists think a giant collision long ago may have knocked Uranus into its strange posture. As you picture this softly glowing, blue-green planet slowly rolling along, its odd rhythm can feel strangely soothing, like a slow, sleepy turn beneath the stars. From there, let your thoughts drift back toward Jupiter, but this time, focus not on its moons or clouds, but on the invisible environment surrounding it. Jupiter's magnetic field is vast and powerful, the strongest of any planet in our solar system. Trapped within this magnetic bubble are belts of charged particles, regions of intense radiation that form dangerous zones around the planet. These radiation belts are similar in concept to Earth's Van Allen belts, but they are far more energetic and hazardous. In these regions, particles move at high speeds and carry enough energy to damage spacecraft electronics and harm unprotected systems in a short time. Even Jupiter's large moons feel the effects, with some experiencing radiation levels that can influence their surfaces and potential environments beneath the ice. To safely explore this beautiful world, spacecraft must follow carefully planned paths and use protective shielding, avoiding the areas where the radiation is strongest. It is a reminder that even the most majestic sights in the solar system can be wrapped in invisible, powerful forces. Now, bring your attention again to the center of everything, the sun. In earlier parts of this bedtime story, you imagined its light and its vibrations. Now, think of its sheer weight. The sun holds almost all the mass in the solar system, well over 99% of everything that exists within its reach. All the planets, moons, asteroids, comets, and drifting dust together make up only a tiny fraction compared to the sun's immense bulk. This enormous mass is what creates the strong gravitational pull that keeps every object, from small grains of rock in the asteroid belt to distant icy bodies, moving in their orbits. Deep in its core, the weight and pressure allow hydrogen to fuse into helium, releasing the energy that becomes the daylight warming Earth and the gentle glow you might see at sunset. Thinking of the sun in this way, as a vast, steady anchor holding the solar system together, can feel comforting, like a constant, dependable presence that has burned for billions of years and will continue to shine for a very long time to come. Finally, let your thoughts move outward once more, beyond Neptune, into the cold, scattered realm of distant ice and rock. Here, far from the warmth of the inner solar system, orbit many small, rounded worlds known as dwarf planets. Pluto is the most famous of these, but it is only one member of a much larger family. Other dwarf planets, such as Eris, Haumea, and Makemake, share similar status, and astronomers keep discovering new candidates in the Kuiper Belt and beyond. The number of dwarf planets in the outer solar system may be far greater than the 8 classical planets closer to the Sun. These icy, remote bodies are like tiny time capsules, preserving material and structures from the earliest days of planetary formation. Though they travel through dim, quiet orbits under a distant sun, they hold valuable clues to how the solar system came to be. As you imagine these small worlds slowly circling in the dark, scattered like gentle lanterns at the edge of space, you can allow their calm, steady motion to help your own thoughts slow down, encouraging your mind to drift deeper toward rest and sleep. As this calming sleep story continues, imagine your awareness drifting once more toward the soft, golden light near the orbit of Venus. You have already visited this world in earlier parts, but now you focus on time itself as it flows across its surface. Venus turns so slowly that its days stretch on and on, far longer than its journey around the sun. In fact, a single rotation on its axis takes more time than a full orbit, making one Venusian day longer than its year. Because of this sluggish spin, sunrise and sunset on Venus are rare and drawn-out events. The planet's thick, cloudy atmosphere traps heat, creating surface temperatures hot enough to melt metal, while crushing pressures press down like an ocean of air. With its slow rotation, heavy clouds, and intense heat, Venus becomes a world of simmering, almost timeless days, where the sun's light is filtered into a hazy glow that never truly feels like our familiar daylight. Just imagining this slow, heavy stillness can make your own sense of time stretch and soften, gently nudging you toward deeper relaxation. Now, let your thoughts drift outward again to Saturn's largest moon, Titan, a world that feels strangely familiar and alien at the same time. From above, Titan shows a thick, orange-tinged atmosphere and dark patches that hint at lakes and seas. But unlike Earth, the liquid that fills Titan's lakes and rivers is not water. In the deep cold so far from the sun, methane and ethane can flow like water, forming liquid pools and channels across the moon's surface. On Titan, clouds and weather systems form in its nitrogen-rich atmosphere, leading to methane rain that falls onto the ground, carves riverbeds, and collects in large, dark lakes near the poles. Some of these lakes are vast, stretching for hundreds of kilometers, with shorelines and inlets shaped by this alien rainfall. Beneath the icy crust, scientists suspect there may also be a hidden ocean of liquid water, insulated from the surface chill. Titan is a place where familiar shapes, coastlines, rivers, clouds, are built from unfamiliar materials, creating a quiet, otherworldly version of a landscape that still feels oddly soothing to picture. Gently now, guide your attention back toward Mars and its two tiny companions, Phobos and Deimos. Unlike large, round moons such as ours, these small bodies are irregular and lumpy, more like captured rocks than polished spheres. Their surfaces are rough and cratered, giving them the look of asteroids that have been tugged into orbit and kept there by Mars's gentle gravity. Many scientists think they may have started their lives as wandering asteroids before being pulled into the Martian system long ago. Phobos moves slowly inward over time, inching closer to Mars with every orbit, while Deimos gradually drifts away. In the far future, Phobos is expected to either break apart into a ring of debris or fall toward the planet's surface. For now, both moons circle quietly above the rust-colored plains, small, silent passengers riding along with Mars around the sun. Imagining them gliding through the darkness, following their steady, unhurried paths, can bring a sense of simple, repetitive calm. Finally, let your thoughts settle once more on Jupiter, but with a new detail in mind. Unlike many planets, Jupiter shines not only with reflected sunlight, but also with warmth it produces from within. The giant world still holds heat left over from its birth, when its massive bulk collapsed together under gravity. Over time, it continues to contract ever so slightly, releasing additional energy and causing Jupiter to radiate more heat than it receives from the sun. This internal warmth helps power the planet's swirling clouds and powerful storms, feeding the bands and eddies that give Jupiter its marbled appearance. In infrared light, Jupiter glows like a softly burning ember beneath its cloud layers, bright and warm against the cold backdrop of space. It is not a star, but it rests just below the threshold of what would have been needed to ignite as one. As you picture this enormous, gently glowing world, it can feel like a quiet hearth at the center of a cold, dark room, steady, comforting, and softly luminous, guiding you deeper into a peaceful, sleepy state. As this gentle sleep story continues, imagine yourself drifting in the quiet dark beyond Uranus, where the deep blue glow of Neptune slowly comes into view. Unlike many other worlds, Neptune was not first spotted by chance through a telescope. Instead, its existence was hinted at by tiny, persistent clues, small irregularities in Uranus's orbit that did not match what gravity from the known planets could explain. Careful observers noticed that Uranus seemed to be tugged by something unseen, as if an invisible companion were pulling softly on its path. In the mid-19th century, mathematicians studied these subtle deviations and used them to predict where an unknown planet would have to be to cause them. They calculated its likely position on the sky, tracing the invisible pullback to a specific region of space. When astronomers finally aimed their telescopes at that predicted point, they found Neptune almost exactly where the numbers said it would be. It was a quiet triumph of celestial mechanics, showing that a distant world could be discovered first through equations and logic, and only later confirmed by the eye. Now, let your thoughts drift from Neptune to Saturn once again, this time to the very top of the planet. At Saturn's North Pole, the atmosphere shapes itself into one of the most surreal patterns in the solar system, a giant, swirling hexagon. This six-sided structure is not carved into rock or ice, but formed entirely from moving clouds and winds. It is a vast jet stream, wider than Earth, wrapped neatly around the pole like a geometric crown. Scientists think this hexagon arises from the way Saturn's atmosphere rotates at different speeds, and how waves of air become trapped and organized around the pole. In laboratory experiments with rotating fluids, similar polygon shapes can appear under the right conditions, hinting at how this natural pattern may form. Still, it feels remarkable that such a precise, geometric figure can emerge on its own from swirling gas. Imagining this enormous, slowly turning hexagon can be oddly soothing, like watching a perfect, softly spinning shape in the sky. Gently now, guide your attention back to the sun, but focus on its outer layers rather than its core. The part of the sun we see and associate with its bright disk, the photosphere, has a very high temperature, thousands of degrees hot. Yet, above this visible surface lies the sun's outer atmosphere, the corona, which is even hotter, reaching temperatures of more than 1,000,000 degrees. This curious increase in heat as you move away from the surface has puzzled scientists for many years. One idea is that waves and motions linked to the sun's magnetic fields carry energy upward, depositing heat into the corona. Another possibility involves countless tiny bursts of energy, small, frequent events that collectively raise the temperature of the outer atmosphere. Whatever the exact mechanism, the result is a halo of extremely hot, thin gas surrounding the sun, glowing with mysterious intensity. Thinking of it as a bright, delicate aura around a familiar star can bring a sense of wonder without urgency, like watching a slow, shimmering flame from a safe distance. Finally, let your mind wander beyond Neptune again, into the wide, cold expanse of the Kuiper Belt. This region forms a broad ring of icy bodies orbiting far from the sun, stretching across billions of kilometers. Here, countless frozen objects, some small and irregular, others large enough to be dwarf planets, move along their quiet paths. Worlds like Pluto, Eris, Haumea, and Makemake live out their long, distant orbits in this deep freeze zone, far beyond the warmth that bathes the inner planets. The Kuiper Belt is made of ancient material left over from the early days of the solar system, much of it still in a primitive, unchanged state. Some objects are nearly spherical, while others tumble through space in irregular shapes, all preserved by the intense cold. This region is like a vast, frozen archive, holding clues to how the outer planets and their moons came to be. As you picture these icy bodies slowly circling in the dark, untouched, unchanged, and deeply quiet, you can let your own thoughts become still as well, drifting calmly like small, peaceful worlds under a distant sun. As this relaxing sleep story continues, imagine drifting far, far beyond the familiar planets, past the icy Kuiper Belt and the orbit of Pluto. Out here, the sun has faded to a bright star behind you, and space feels incredibly wide and quiet. In this distant darkness, many astronomers believe there may be a vast, spherical shell of icy objects surrounding the solar system, known as the Oort cloud. If it exists, this cloud could extend almost a light year from the sun, forming a gentle, distant halo of frozen bodies softly bound by gravity. These faraway objects would be loosely held, so sensitive that the slow passage of nearby stars or the pull of the galaxy itself could disturb them. From time to time, one of these icy wanderers may be nudged inward, falling toward the inner solar system and appearing to us as a long-period comet with an elongated, unpredictable path. If the Oort cloud is truly there, it marks a kind of outer border to the sun's influence, a quiet frontier where the solar system gradually gives way to the wider galaxy. Imagining this remote shell can feel like picturing the edge of a dream, soft and indistinct, yet peaceful. Gently now, let your thoughts turn back toward Jupiter and one of its most dramatic moons, Io. Unlike many icy, quiet moons in the outer solar system, Io is fiercely active. Its entire surface is shaped and reshaped by constant volcanic eruptions, making it the most volcanically active world known. Instead of calm, frozen plains, Io displays bright yellows, deep reds, and dark patches made from sulfur and other volcanic materials, spread across a restless landscape. The source of all this activity is tidal heating. As Io orbits Jupiter, it is pulled and flexed by the giant planet's strong gravity and by the gravitational influence of neighboring moons. This repeated squeezing and stretching generates friction inside Io, heating its interior and fueling powerful eruptions. Some volcanic plumes even shoot hundreds of kilometers above the surface. While Earth's crust gradually cools and settles over time, Io remains young and ever-changing, like a glowing ember of geology in the cold, outer reaches of space. Next, let your awareness drift back out to Neptune. and to its largest moon, Triton. Triton moves in a direction opposite to Neptune's rotation, tracing a backward path known as a retrograde orbit. This unusual motion suggests that Triton was not born alongside Neptune, but was likely captured long ago from the distant icy regions of the solar system. That capture may have caused great disruptions, possibly altering or even destroying earlier moons before the system settled into the configuration we see today. Despite its distance and cold, Triton is not completely still. It shows signs of geological activity, including icy geysers or cryovolcanoes that release frozen material into space. Triton also has a very thin atmosphere that can change with the seasons, appearing and fading as conditions shift. It is a world that moves in reverse, quietly challenging expectations about how moons should form and behave, yet drifting along its path with calm persistence. Finally, guide your thoughts gently back homeward to Earth and its companion in the night sky. Compared to the size of our planet, Earth's moon is unusually large. For a rocky world, having such a big satellite is rare, making our moon stand out among the moons of the inner solar system. Its diameter is roughly 1/4 that of Earth, a proportion more commonly seen in dwarf planet moon pairs than around full-sized planets. Most scientists think the moon formed after a massive collision in the early history of Earth. In that ancient impact, a Mars-sized body likely struck the young planet, sending material into orbit that eventually gathered into the moon. Over billions of years, this close partnership has helped shape Earth's tides, influenced its climate, and contributed to the long-term stability of its tilt. As you imagine the moon quietly circling our world, night after night, you might feel a sense of deep continuity, a reminder that even dramatic beginnings can lead to long, gentle companionship. As this gentle nighttime sleep story continues, imagine zooming out to see the solar system from above, all its planets tracing their paths around the sun. It is easy to picture those paths as perfect circles, smooth and even. In reality, each planet follows an ellipse, a slightly stretched circle, with the sun resting off-center. Because of this, every planet has a moment when it is closest to the sun, called perihelion, and a moment when it is farthest, called aphelion. The difference is subtle for some worlds, and more dramatic for others, but it creates a quiet rhythm in how sunlight and distance change over the course of a year. This elliptical motion was carefully described centuries ago by Johannes Kepler, who realized that the planets travel faster when they are nearer to the sun and slower when they are farther away. His work shifted the way people understood the structure and grace of the solar system, revealing that its beauty lies not in perfect circles, but in slightly stretched paths that still feel smooth and harmonious. As you picture these gentle ovals of motion, the planets moving steadily along their routes, you might feel your own thoughts falling into a slow, predictable pattern, comforting and calm. Far beyond the visible planets, in the distant darkness at the edges of the sun's reach, some comets begin their journeys. The long-period comets that appear only once in many lifetimes are thought to come from a remote reservoir of icy objects, drifting in orbits so large they stretch almost to interstellar space. These comets are loosely tied to the sun, and a passing star or the tidal pull of the galaxy can nudge them from their quiet paths. When that happens, they begin a long fall inward, curving slowly toward the inner solar system. After spending billions of years in cold, silent darkness, a disturbed comet can flare into brilliance as it nears the sun, growing a glowing coma and a long, delicate tail. For a short time, it may be visible from Earth as a bright, ghostly streak across the night sky. Then it retreats again, or is transformed and diminished by its close passage. Thinking of these rare visitors, ancient, quiet travelers that occasionally reveal themselves, can be soothing, like watching a distant lantern appear at the edge of a dark field, and then slowly fade. Now let your thoughts rest once more on the sun, but this time, imagine it far in the future. Like all stars of its kind, the sun has a life cycle. In billions of years, after it has used up the hydrogen at its core, it will swell into a red giant, growing large enough to transform the inner part of the solar system. Eventually, it will shed its outer layers, releasing a glowing shell of gas that will gently drift away into space. What remains at the center will be a white dwarf, a dense, Earth-sized remnant made mostly of carbon and oxygen. This small star core will no longer generate new energy in the same way, but will slowly cool and fade over incredibly long spans of time. In that distant era, the sun will be like a quiet ember, glowing softly in the dark. Imagining this far-off future can bring a sense of perspective, reminding you how small a single day is compared to the long, slow story of a star. Finally, let your attention return to Mars. Though colder and thinner in atmosphere than Earth, Mars also experiences seasons. The key lies in its axial tilt, which is similar to Earth's. As Mars moves around the sun, this tilt causes one hemisphere and then the other to lean slightly toward the light, creating cycles of spring, summer, autumn, and winter, just as on our own world, but stretched out over a longer year. Martian seasons affect more than just temperature and light. They influence the growth and retreat of polar ice caps, the patterns of dust storms, and subtle shifts in air pressure. Because Mars takes nearly twice as long as Earth to complete its orbit, each season lingers, unfolding slowly and quietly. As you picture the red planet moving through its gentle seasonal changes under a pale sky, you may feel your own inner pace slowing to match, helping your mind and body sink deeper into rest. As this soothing sleep story drifts onward, imagine returning once more to the realm of Jupiter, this time focusing on a single, enormous moon circling within its vast magnetic field. This moon is Ganymede, the largest natural satellite in the solar system, so big that it surpasses even the planet Mercury in size. Beneath its surface lies a complex interior, a rocky core, layers of ice, and strong hints of hidden oceans stacked like pages in a quiet, frozen book. Its crust is marked by ridges, grooves, and ancient scars, evidence of a long and intricate history. Ganymede is also unique among moons because it has its own internal magnetic field, a feature usually associated with full-sized planets. This magnetism interacts with Jupiter's powerful environment to create soft auroral glows in Ganymede's thin atmosphere, ghostly lights shimmering above an otherwise dark and silent world. Scientists suspect there may be multiple layers of salty water trapped between sheets of ice deep below the surface, forming a layered ocean system unlike anything on Earth. Yet, despite its size and hidden richness, Ganymede continues to move quietly through Jupiter's shadowed domain, unhurried and serene. Now, let your awareness drift outward again to the dim and distant orbit of Pluto. Most of the time, Pluto travels farther from the Sun than any of the classical planets, but its path is stretched into a long ellipse. Because of this, there are periods when Pluto actually comes closer to the Sun than Neptune. During such intervals, Pluto temporarily becomes the nearer of the two, moving inward on its elongated track. Even so, Pluto and Neptune never collide or even come particularly close to each other. Their orbits are locked into a stable resonance. For every 3 journeys Neptune makes around the Sun, Pluto completes exactly 2. This precise gravitational rhythm keeps the two bodies safely separated, their paths weaving in a way that always avoids a direct encounter. It is like a slow, cosmic dance in which each partner follows a set of steps that never overlap, guided by the steady music of gravity and time. Gently now, let your thoughts settle once more on the Sun, not as a constant, unchanging sphere, but as a star with its own cycles and heartbeat. Roughly every 11 years, the Sun's magnetic field flips, with its north and south magnetic poles trading places. This cycle is linked to complex motions of hot plasma beneath the surface and is reflected in changes in sunspots, solar flares, and eruptions of charged particles into space. At the high point of this cycle, called solar maximum, the Sun is more active, with more frequent and intense bursts of energy. Later, as the cycle winds down towards solar minimum, the surface appears calmer and less disturbed. These changes influence the space environment around Earth, touching satellites, radio signals, and the shimmering curtains of auroras near the poles. Thinking of the Sun's magnetism as a slow, repeating breath, a magnetic heartbeat, can be strangely comforting, a reminder that even stars move through gentle, predictable rhythms. Finally, turn your attention to a common idea many people carry, that planetary alignments might cause disasters on Earth. It can be tempting to think that when several planets line up, their combined pull could trigger earthquakes, floods, or other dramatic events. In reality, the gravitational influence of those distant planets on Earth is extremely small, far weaker than the pull of our own moon or the Sun. Even in rare, visually striking alignments, their combined effect on our planet is negligible. The moon, being close and massive relative to its distance, has a far greater impact on tides and small changes in stress within Earth's crust than any grouping of remote planets ever could. Planetary alignments are beautiful to imagine and fascinating from a mathematical and visual point of view, but they do not serve as omens or causes of catastrophe. Instead, they are simply elegant arrangements in the sky, a silent choreography of distant worlds, gliding along their paths in peace As this calming nighttime story continues, imagine your awareness riding along with a small, silent spacecraft, leaving the familiar warmth of the inner planets behind. Escaping the sun's pull is a slow, patient journey. Probes like the Voyagers, launched decades ago, have spent more than 40 years gliding outward before finally reaching the boundary where the sun's influence gives way to the space between the stars. They travel at tens of thousands of kilometers per hour, yet the distances are so vast that it still takes decades to cross from one region to the next. Those spacecraft have passed the orbits of the outer planets, moved through the distant icy zones, and continued into the dim frontier beyond. Their instruments still send back faint signals, and each carries a golden record with sounds and images from Earth. Waves and wind, music and greetings, tiny echoes of home. Far from the sun, they drift on in darkness, acting as quiet, enduring messengers of our world to whatever might someday find them. Now, let your thoughts return gently to Earth, wrapped in an invisible protective bubble deep within the planet. Slow currents of molten metal create a magnetic field that stretches far out into space. This field turns away many of the charged particles streaming from the sun, helping to shield the atmosphere and surface from harmful radiation. Without such protection, Earth's air and water could gradually be stripped away, as appears to have happened to more exposed worlds like Mars. Some of the particles that do reach Earth are guided along the magnetic field lines toward the polar regions. There, they meet molecules in the upper atmosphere and cause them to glow, painting the sky with shimmering curtains of green, red, and violet light, known as auroras. This magnetosphere is not a rigid shell, but a dynamic, shifting shield that has quietly helped preserve Earth's climate and life for immense spans of time. As you drift further into this sleep story, imagine looking up at the moon. It feels steady and constant, yet its orbit is slowly changing. Each year, the moon moves a few centimeters farther away from Earth. This gradual retreat is driven by the subtle exchange of energy between Earth's rotation and the tides raised by the moon's gravity. Long ago, the moon was much closer and would have appeared larger in the sky, while Earth's days were shorter. As the moon slowly recedes, Earth's rotation very gradually slows, making the length of a day increase by tiny amounts over long timescales. In the far future, the moon will be too distant to create the kind of perfect total solar eclipses we see today. Even though the night sky looks unchanging from one evening to the next, it too is evolving, shaped by slow motions that unfold over billions of years. Finally, let your awareness drift once more to the outskirts beyond Neptune, where the Kuiper Belt holds countless icy worlds. Among them are small bodies with surfaces so bright they shine like mirrors in the dim sunlight. One such object spins so quickly that it has taken on an elongated, football-like shape, its exterior coated in crystalline water ice that reflects light efficiently. Another is so reflective that it bounces back nearly all the sunlight that touches it, making it brighter than clean, fresh snow would appear if placed in space. These distant worlds may have been resurfaced by icy eruptions, collisions, or slow chemical changes that renew their outer layers. In the cold darkness at the edge of the sun's reach, they glint faintly, catching and returning a little of the light that reaches them. As you picture these remote, shining bodies, cold mirrors hanging in a quiet, frozen dusk, let their stillness and pale glow help your thoughts soften and your breathing slow, guiding you deeper into rest. As this relaxing sleep story continues, imagine drifting back toward the soft, golden realm of Saturn, focusing now on one of its smaller, gleaming moons, Enceladus. Though modest in size, Enceladus hides a remarkable secret beneath its bright, icy crust. Near its south pole, long fractures in the surface, often called tiger stripes, serve as vents where towering plumes of water vapor and ice crystals spray gently out into space. Beneath the ice, tidal forces from Saturn's gravity generate heat, keeping a subsurface ocean in motion and supplying energy to drive these distant geysers. The material in Enceladus's plumes contains salts, organic compounds, and hints of warm water interacting with rock on the seafloor, suggesting that hydrothermal activity may be happening in the dark ocean below. Some of the sprayed water falls back as fine snow, while some escapes and helps feed Saturn's faint E-ring, forming a living, shimmering link between the moon and its planet. As you picture these slow, graceful fountains of ice rising into the blackness and drifting outward like frozen breath, you can let your own breathing become softer and more peaceful. Now, guide your thoughts toward the small rocky bodies that wander between and beyond the planets, the asteroids. It is easy to imagine them as solid chunks of stone, but many are far more fragile. Some asteroids are rubble piles, loose heaps of rocks, gravel, and dust, held together only by their own gentle gravity. These objects likely formed when larger asteroids were shattered in collisions, with the fragments gradually drifting back together into new, loosely bound shapes. Because they are not solid all the way through, rubble pile asteroids can contain large empty spaces and respond strangely to forces. They may wobble as they spin, shift slightly under impact, or slowly change shape over time. Spacecraft that have visited such bodies have revealed their porous, delicate nature, showing that these are not monolithic relics, but ancient, drifting ruins from the early days of planet building. Imagining them quietly circling the sun, piles of stones just barely hanging together, can be surprisingly calming, a reminder that not everything in the universe has to be perfectly solid to endure. Gently now, let your awareness return to the innermost planet, Mercury. Though Mercury is small, its interior is dominated by an unusually large metallic core that takes up a much greater fraction of its volume than Earth's or Venus's. Above this core lies only a relatively thin shell of rocky material, like a slender crust wrapped around a heavy metal heart. The exact reason for this structure is still being studied, leaving room for several possibilities and quiet mysteries. Some scientists suggest that Mercury might once have been wrapped in a thicker rocky mantle that was stripped away by a massive impact early in its history. Others think it may have formed in a region of the young solar system where conditions favored the accumulation of heavy elements like iron over lighter rock. Whatever the cause, Mercury stands as a dense, metal-rich survivor, a small world whose whose oversized core and subtle magnetic field reflect the turbulent conditions of the solar system's youth. Finally, let your thoughts drift once more to Venus, the bright evening star or morning star, often seen near the horizon. Among the rocky planets, Venus shares many similarities with Earth in size and composition. Yet, one difference is hard to miss. Venus has no moon at all, while Earth has a large, steady companion in the night sky. Venus circles the sun alone, with no satellite to mark its nights. The reasons for this solitude are not fully known. Some ideas propose that Venus may once have had a moon that was later lost through a collision or pulled back down by gravity. Others point to Venus's slow, backward retrograde rotation as a factor that might make long-term stable orbits for moons more difficult. Whatever the explanation, Venus now orbits as a single, cloud-wrapped world without a lunar partner, glowing quietly in the twilight. As you picture this solitary planet, shining softly in the dark, you can allow yourself to feel more and more at ease, as if you too are gently floating in a peaceful, moonlit sky. As this gentle sleep story continues, imagine drifting outward again into the realm of the giant planets, where the night is deep and the worlds are immense. Around these giants, moons gather like a family of small, shining companions, while the inner rocky planets have only a few small satellites, Earth with one, Mars with two. The gas and ice giants are surrounded by dozens of moons of many shapes and sizes. Some are tiny, captured fragments of rock and ice, while others, like Ganymede and Titan, are large, complex worlds with their own atmospheres and internal oceans. Uranus and Neptune also host their own clusters of icy moons, some with tilted orbits and hidden layers of water beneath their frozen shells. Together, these systems resemble miniature solar systems, with the giant planets acting as central anchors that slowly gathered material over long stretches of time. The farther you travel from the sun, the more common these companions become, as if gravity quietly collects and keeps them close in the cold. Imagining these moons circling in slow, steady paths can feel like watching a peaceful mobile turning above a sleeping child's bed. Now, bring your awareness closer to home, to a telescope that orbits just above Earth's atmosphere, the Hubble Space Telescope. From its quiet perch, Hubble has spent decades watching not only distant galaxies and nebulae, but also the planets of our own solar system. Its sharp vision has captured intricate cloud patterns on Jupiter, evolving storms on Neptune, and seasonal changes on Mars, offering a long, continuous record of their shifting weather and light. These images complement the brief visits of passing spacecraft, allowing scientists to follow storms as they form, grow, and fade, and to observe delicate ring structures and auroras over time. From low Earth orbit, Hubble looks outward with remarkable clarity, catching subtle details in ultraviolet and visible light. You can imagine it as a calm, steady eye, patiently watching the changing faces of our neighboring worlds as years quietly pass. Gently now, let your thoughts rest on one of Jupiter's most famous features, the Great Red Spot. This enormous storm sits in the planet's southern hemisphere, a swirling oval large enough to fit multiple Earths side by side. It has been observed for centuries, appearing in some of the earliest telescopic records from the 1600s. Over time, the storm has shifted in shape and size, gradually shrinking in recent decades, yet it continues to rage on, its winds circling at hundreds of kilometers per hour. The reddish color of the storm may come from complex chemical reactions in Jupiter's atmosphere, where sunlight interacts with molecules high above the clouds. Whatever its exact makeup, the Great Red Spot is a reminder of how different weather can be on a gas giant, where storms can endure not just for days or weeks, but for many human lifetimes. Imagining this vast, slowly turning vortex can be strangely soothing, like watching a distant, ever-spinning whirlpool of colored clouds. Finally, guide your awareness back to Neptune, the far-flung blue giant at the edge of the known planets. Although it receives only a faint fraction of the sunlight that warms Earth, Neptune is not a quiet, frozen sphere. It actually gives off more energy than it receives from the sun, radiating internal heat that stirs its atmosphere into motion. This hidden warmth helps power powerful winds and storm systems, including the fastest winds measured anywhere in the solar system. The precise source of Neptune's internal heat is still being studied, with possibilities including leftover energy from its formation, slow contraction under gravity, and radioactive decay deep within its core. Whatever the cause, the effect is a world with a cold, distant exterior, but a surprisingly active and restless atmosphere. As you picture Neptune dark, serene, yet alive with unseen energy, you can let that image guide you into deeper calm, feeling your own thoughts settle like soft clouds in a quiet, starlit sky. As this gentle sleep story continues, bring your awareness back to the world beneath your pillow. Earth. One of the most quietly remarkable things about our planet is the way water lives here in all three familiar forms at once. Solid ice forms bright caps and glaciers. Liquid water fills oceans, lakes, and rivers, and invisible vapor and soft clouds drift through the air. Together, they move in a continuous cycle, melting, freezing, evaporating, and condensing, linking sea and sky and land in a smooth, unbroken flow that quietly supports life. This delicate balance is possible because Earth sits at just the right distance from the sun, with suitable temperature and pressure at the surface. Other worlds may hold water as buried ice, thin vapor, or hidden underground seas, but none show the same global, dynamic presence that Earth does. Here, water runs, falls as rain or snow, and rises again as mist, tracing patterns that repeat gently through seasons and ages. Imagining this endless, life-sustaining dance of water can be soothing, like watching waves slowly roll in and out on a calm shoreline. Now, let your mind move outward again to the far edges of the sun's influence. The solar wind, streams of charged particles flowing from the sun, expands in all directions, forming a kind of bubble around the solar system called the heliosphere. Eventually, this outflow meets the thin gas and dust that exist between the stars. And at a certain distance, the outward push of the solar wind becomes balanced by the pressure of the surrounding interstellar medium. This boundary is called the heliopause, and it marks the place where the solar wind's strength finally gives way. Spacecraft like Voyager 1 and Voyager 2 have spent decades traveling outward, and both have now crossed this boundary, entering what is considered interstellar space beyond the heliopause. The sun's gravity still reaches, but its energetic wind no longer dominates. You can think of the heliopause as the soft, outer surface of the sun's protective breath, the place where our star's immediate influence fades and the wider galaxy begins. Gently now, imagine zooming out even farther until you can picture the entire solar system, sun, planets, comets, and all moving together through space. We are not resting in a fixed spot. Instead, the sun and its planets drift slowly through a patch of interstellar material known as the local interstellar cloud, part of a larger, bubble-like region shaped long ago by powerful stellar explosions. This cloud is very thin by everyday standards, but on cosmic scales, it is a meaningful feature of the space around us. As the solar system moves through this subtle fog, the heliosphere acts like a protective bow wave, deflecting much of the incoming material and altering the flow of cosmic rays that reach the inner regions. Scientists study this environment to better understand how it shapes the boundary of the heliosphere and how conditions outside might, in very small ways, influence the space around Earth. Thinking of our entire solar system as a ship slowly sailing through a quiet, galactic mist can be comfortingly serene, like drifting along a calm, starlit sea. Finally, let your thoughts return to the many moons you have visited throughout this story. Not all of them are still and frozen. Several are geologically active, showing that energy and change are not limited to planets alone. Io, circling close to Jupiter, is covered in erupting volcanoes, and Enceladus near Saturn sends plumes of water vapor and ice into space from a hidden ocean below. Europa and Ganymede probably hold deep subsurface seas warmed by internal heat. Even far-off Triton, orbiting Neptune backward, shows signs of icy eruptions that reshape its surface. These moons, once thought of as simple, dead ice balls, are now seen as restless worlds with their own internal warmth, shifting crusts, and perhaps even the ingredients needed for life. As you picture them small, distant, and quietly active beneath their frozen exteriors, you can allow that sense of subtle, hidden motion to lull your mind. Just as these moons continue their slow, steady changes in the dark, you can let your own thoughts soften and settle, drifting deeper into rest. As this gentle sleep story continues, imagine your awareness gliding far beyond Neptune to the dim, distant orbit of Pluto. Although this small world spends most of its long year in deep cold, it is not entirely airless. Pluto carries a thin, fragile atmosphere made mostly of nitrogen, with small amounts of other gases mixed in. When it moves closer to the sun along its stretched, elliptical path, some of the surface ice slowly turns directly into gas, creating a soft, hazy envelope that rises above the ground and drifts into space. As Pluto travels outward again and the sunlight weakens, this delicate atmosphere cools and begins to settle back down. The gases refreeze onto the surface like frost, and the airy shell thins and collapses over the course of its 248-year orbit. Pluto's atmosphere breathes in and out like this, appearing and fading with its changing distance from the Sun during a close spacecraft flyby. This temporary envelope was seen as a layered, bluish haze around the planet, a brief halo of light around a world that spends much of its existence in quiet, frozen twilight. Now let your thoughts move inward to the heart of the solar system, deep inside the Sun itself. At the Sun's core, temperatures climb to well over 15 million degrees, and the pressure is immense. In that environment, hydrogen atoms are pressed so tightly together that they fuse into helium, releasing vast amounts of energy. This continuous fusion is what powers the Sun's glow, providing the light and warmth that bathe the planets and sustain life on Earth. The energy created in the core does not rush out all at once. Instead, it slowly makes its way through dense layers of hot plasma, bouncing and scattering in all directions for hundreds of thousands of years before finally reaching the surface. From there, it streams into space as light and other forms of radiation, taking just over 8 minutes to cross the distance to Earth. The calm, steady sunshine you feel is the gentle, filtered result of an extremely hot and active center, softened by distance and time. Gently now, guide your awareness back to Uranus, the sideways planet you visited earlier in the story. In addition to its unusual tilt, Uranus is also encircled by a set of thin, faint rings. These rings are composed of small bits of dark rock and ice, far less bright and dramatic than Saturn's, and were only discovered relatively recently when they briefly blocked the light of a distant star. There are several distinct rings, many of them narrow and sharply defined, likely shaped and maintained by the gravity of small nearby moons. Because Uranus is tilted almost onto its side, its rings, too, are tipped dramatically. Seen from certain angles, they can appear almost vertical, like dark, delicate lines encircling a planet that is turned nearly onto its edge. They are subtle and shadowy, easy to overlook, yet always there, quiet bands of debris tracing calm circles around a softly glowing, turquoise world. Finally, let your thoughts drift outward one more time, not to a single planet or moon, but to the large, protective structure that surrounds them all. The Sun constantly releases a stream of charged particles known as the solar wind, which flows outward in every direction. This flow carries the Sun's magnetic field with it, forming a vast, bubble-like region around the solar system called the heliosphere. Within this magnetic bubble, much of the harsh radiation from the galaxy beyond is softened or deflected, helping to shelter the planets inside. The heliosphere stretches well past the orbits of the known planets, enclosing comets and distant icy bodies. Its outer boundary is where the solar wind slows and gives way to the pressure of the thin gas and particles that fill the space between the stars. As the Sun slowly orbits the center of the Milky Way, this magnetic bubble moves with it, like a gentle shield carrying the solar system through changing regions of interstellar space. Imagining this great, protective envelope drifting through the galaxy can be deeply calming, like picturing a softly glowing lantern floating through a quiet, endless night. As this calming sleep story continues, imagine once more the small, sun-baked world of Mercury, circling close to the bright center of the solar system. For a long time, astronomers noticed that Mercury's orbit behaved a little differently than expected. The point where it passed closest to the Sun, its perihelion, shifted slowly over time in a way that classical physics could not quite explain. The discrepancy was tiny, but persistent, like a faint whisper that something in the old description of gravity was incomplete. In the early 20th century, Albert Einstein's theory of general relativity offered a new way of understanding gravity, not as a simple force, but as the bending of space and time around massive objects. According to this theory, the Sun's great mass subtly warps the region around it, slightly altering the paths of nearby planets. When scientists used relativity to calculate Mercury's orbit, the predicted shift in its perihelion matched the observed value perfectly. This elegant agreement became one of the first major confirmations of Einstein's ideas, showing that even the path of a scorched, rocky planet carries clues about the deep structure of the universe. Now bring your attention gently back to Earth and its familiar companion in the night sky. The moon does more than soften the darkness. It quietly shapes the rhythms of our oceans. Its gravity pulls on Earth's water, creating bulges on the side facing the moon and on the opposite side as well. As Earth rotates through these bulges, coastlines pass in and out of the swollen areas of water, giving rise to the regular pattern of high and low tides. The Sun's gravity adds its own influence, sometimes aligning with the moon to create higher spring tides, and sometimes working at angles that produce gentler neap tides. These tidal forces do not act only on the seas. Very slightly, they also tug on Earth's crust and can play a role in the gradual slowing of the planet's rotation over long spans of time. You can imagine the moon as a quiet partner, pulling and releasing with each passing day, keeping the oceans in slow, steady motion. Thinking of this gentle, predictable rise and fall can be deeply soothing, like listening to distant waves rolling in and out on a calm shore. Gently now, let your thoughts drift back to the far edges of the solar system, beyond Neptune, where icy objects follow long, stretched-out orbits. Astronomers studying these distant bodies have noticed that some of their paths seem oddly clustered and tilted, hinting at the possible pull of something large and unseen. One idea is that there may be an undiscovered planet, often called Planet 9, far beyond Pluto, whose gravity quietly shapes the motions of these remote objects. If such a world exists, it could be several times more massive than Earth, traveling on a distant, elongated orbit that takes thousands of years to complete a single journey around the Sun. So far, no telescope has directly spotted this hidden planet, and it remains a possibility rather than a certainty. Still, the search continues, and the idea that another large, faint world might be circling in the darkness adds an extra layer of mystery to the outer solar system, like a softly suggested note at the edge of a familiar melody. Finally, guide your awareness inward again to Jupiter and its outermost large moon, Callisto. At first glance, Callisto appears to be a quiet, heavily cratered world, its surface ancient and seemingly unchanged for billions of years. Yet beneath that battered crust, there may be more happening than meets the eye. Measurements of its magnetic environment and other data suggest that a layer of electrically conductive material, likely a salty ocean, could lie hidden deep below the ice. If this subsurface sea is real, Callisto would be another member of the solar system's family of ocean worlds, alongside Europa and Ganymede. Its ocean would be buried under thick ice, dark, cold, and silent, but potentially holding many of the ingredients needed for life. As you imagine this hidden water, sealed away beneath an old, cratered shell, you can let the image of a calm, undisturbed sea settle over your thoughts, helping your mind grow still and quiet, like a deep ocean beneath a frozen, starlit surface. As this gentle sleep story continues, imagine turning your attention once more to Venus, the bright star-like point that sometimes appears in Earth's evening or morning sky. It orbits farther from the sun than Mercury, yet its surface is far hotter. The reason lies in its thick, heavy atmosphere, made mostly of carbon dioxide, wrapped in layers of reflective clouds. This blanket traps heat in a powerful greenhouse effect, preventing warmth from escaping back into space and causing surface temperatures to rise to levels that can melt metal. Sunlight filters through the clouds and warms the ground, but the dense air and cloud layers act like a sealed oven, letting energy in more easily than it can get out. By contrast, Mercury has almost no real atmosphere and loses heat quickly on its night side, leading to extreme swings between hot and cold. Venus shows that distance from the sun is only part of the story. The nature of a planet's atmosphere can be even more important in deciding how warm or cold its surface becomes. Now let your thoughts drift outward to Saturn, where the most iconic rings in the solar system circle a pale, banded giant. From a distance, Saturn's rings look like solid, shining disks, but up close, they are revealed to be made of countless individual pieces. Most are water ice, from tiny grains of frost to chunks as large as boulders or small houses, all orbiting together in an incredibly flat, thin plane. Their icy composition gives the rings a bright, reflective sheen, making them stand out against the darkness of space. Within the rings, gravity and motion carve delicate structures. Narrow gaps, ripples, and fine ringlets appear where small moons and gravitational resonances disturb the flow of particles. The result is a constantly evolving pattern of waves and divisions, a dynamic sculpture of ice in motion. As you picture this vast, shimmering disk of frozen fragments turning slowly and silently around Saturn, you can let your own thoughts scatter and then gently settle, like ring particles finding their calm orbits. Next, guide your awareness inward to the broad belt of rocky objects between Mars and Jupiter, and to its largest resident, Ceres. Ceres is big enough that its own gravity has pulled it into a roughly spherical shape, setting it apart from many irregular asteroids. Because of this, it is classified as both the largest asteroid in the main belt and a dwarf planet, a hybrid world that sits at the crossroads between categories. Beneath its surface, there may be layers of salty water or muddy ice, hinting at a more complex interior than a simple rock. When a spacecraft visited Ceres, It found bright patches on its surface that looked like scattered lights against darker ground. These turned out to be deposits of salt left behind when briny water or slushy material reached the surface and evaporated, leaving reflective minerals behind. Ceres, with its mix of rock, ice, and salts, offers a glimpse into the early building blocks of planets, a quiet, intermediate world that has preserved ancient ingredients in a small, self-contained sphere. Finally, let your thoughts return to Mars, the red world that has appeared several times in the story. Its distinctive color comes from fine dust rich in iron that coats much of its surface over long periods of time. This iron-bearing material reacted with traces of oxygen in the thin atmosphere, forming iron oxides, the same family of compounds that make rust on Earth. As winds lifted and spread this dust, it settled over rocks, plains, and hills, giving Mars its characteristic reddish-brown tone. This dust is so widespread that it can tint the sky during storms and color almost every landscape on the planet. Yet Mars is not uniform. There are also darker volcanic plains and bright polar caps that add subtle variations to its appearance. From afar, though, the rusty hue dominates, signaling a cold desert world where iron-rich dust has quietly transformed over billions of years. As you imagine this softly tinted planet hanging in the dark, you can allow that steady, muted color to wash over your thoughts, leaving them quiet, even, and ready for deeper rest. As this gentle sleep story continues, bring your attention once more to the sun, the steady star at the center of everything. Its surface is unimaginably hot, yet when you look closely, some regions appear darker than the rest. These are sunspots, slightly cooler patches where strong magnetic fields interfere with the normal flow of energy rising from below. They are not truly cold. Each one still burns at thousands of degrees, but compared to the brighter surroundings, they stand out as dusky marks on the glowing disk. Sunspots can grow larger than Earth and often appear in groups, forming and fading over days or weeks. Their numbers rise and fall in a repeating cycle of about 11 years, tracking changes in the sun's overall magnetic activity. As you picture these temporary, darkened swirls drifting across the solar surface, you might think of them as small, shifting scars that hint at the hidden motions inside the star, quiet signs of a deeper rhythm beneath the seemingly calm sunlight that reaches you each day. Now, let your thoughts drift outward to the pale greenish-blue world of Uranus. Unlike the planets that have been known since ancient times, Uranus entered human awareness only in the age of telescopes. An astronomer carefully scanning the sky noticed a point of light that did not behave like a normal star. Over time, it became clear that this object was slowly moving against the background, following a path that marked it as a planet, not a distant sun. This discovery extended the known boundaries of the solar system and signaled a new era in which instruments would reveal worlds too faint to see with the unaided eye. Since then, Uranus has surprised observers with its extreme tilt, faint rings, and collection of icy moons. You can imagine it as a quietly revolutionary presence in the night sky, an unassuming dot that, once recognized, gently redrew the edges of our cosmic map. Gently now, turn your awareness to time itself and the long history of the solar system by examining ancient meteorites, the oldest rocks on Earth, and samples from the moon. Scientists have pieced together an age of about 4.6 billion years. Long before any planets existed, there was a cloud of gas and dust, slowly swirling in space. Under its own gravity, this cloud collapsed, growing denser and warmer at the center until the sun was born. Around the young star, leftover material began to clump together, grains forming pebbles, pebbles forming larger bodies, and eventually growing into planets, moons, and smaller objects. Collisions, migrations, and long eras of cooling gradually produced the relatively stable system seen today. As you picture this process, dust becoming rocks, rocks becoming worlds, over spans of time far beyond a single lifetime, everyday concerns can feel small and distant, like brief ripples on a deep, ancient sea. Finally, guide your thoughts to Vesta, one of the largest bodies in the asteroid belt. Vesta is more than just a simple rock. Inside, it has layers reminiscent of a tiny planet. Beneath its rugged surface lie a mantle and a dense core, evidence that it once grew hot enough for its interior to melt and separate by weight. This process of forming distinct internal layers, known as differentiation, is the same basic step that shaped the larger rocky planets, including Earth. A gigantic impact at Vesta's south pole carved a vast basin and may have exposed some of the deeper material, offering a fleeting glimpse into its structure. In many ways, Vesta is like a frozen time capsule from the early solar system, a planetary building block that never quite grew large enough to become a full planet. As you imagine this small, layered world drifting quietly in the darkness, you can let the image of a half-formed planet, ancient, stable, and unhurried, help your own thoughts slow and settle, preparing you for deeper rest, far beyond the orbits of the planets, past the hazy boundary where the sun's influence begins to thin. A small, aging spacecraft continues its slow journey into the dark. Voyager 1, launched more than 4 decades ago, is now traveling through interstellar space, the thin expanse of gas and particles that lies between the stars. Its power is fading, and many of its systems have been carefully switched off to conserve energy. Yet some instruments still listen and measure, quietly recording the behavior of cosmic rays, magnetic fields, and the sparse plasma around it. Each signal it sends back to Earth is incredibly faint and takes more than 20 hours to arrive, crossing billions of kilometers before being caught by listening antennas. The spacecraft runs on a small nuclear power source, just enough to keep its remaining instruments and transmitter alive. From that great distance, every bit of data it returns is like a whisper from the edge of human reach, a gentle reminder that something built by human hands is still moving outward, beyond the familiar glow of our sun. Now, let your thoughts drift even farther out, to imagine the solar system not as something still and fixed, but as a traveler itself. While the planets orbit the sun is also journeying around the center of the Milky Way galaxy. This grand orbit takes on the order of a couple 100 million years to complete, a span so large It is sometimes called a cosmic year. During that time, the solar system slowly passes through different regions of the galaxy, gliding through patches of interstellar gas, drifting near spiral arms, and moving past distant star-forming areas over immense timescales. This motion may change the environment around us, affecting how many comets are nudged inward or how much interstellar material presses against the heliosphere. Yet on any given night, it feels perfectly still from your vantage point on Earth. You, the planets, and the distant probes are all riding together on this vast, slow spiral, circling the galaxy like passengers on a cosmic carousel. And now, this quiet journey through our solar system, the gentle bedtime story you've been listening to, comes to a soft, unhurried pause. From the scorched inner worlds close to the sun, to the drifting rubble of the asteroid belt, from volcanic moons and hidden oceans to the icy edges where comets sleep, your imagination has wandered far tonight, one relaxing fact at a time. If your eyes feel heavy now, that is exactly how this nighttime sleep story is meant to find you. Allow whatever images remain rings of ice, distant storms, quiet blue hazes to fade slowly into the background of your mind. Let your breath fall into an easy rhythm and let your body grow heavier against the bed, as if you are gently floating in the dark between the stars. There will always be more to learn, more worlds to visit, more sleepy facts to explore with Sleepy Story Facts on another night. But for now, you have traveled far enough. Whenever you need a calming sleep story or a peaceful way to drift off, you can always return to this quiet space among the planets and moons. For tonight, there is nothing more you need to do, nowhere else you need to go. May your dreams be soft, your rest deep, and your night peaceful. Good night, and sleep well.